Good morning, students. Today I am going to explain further the rest of the operators which we were doing in the previous lecture. So there are next operator type is your multiplying operators. So this is the one of the VHDL operators types. So in this multiplying operators, we have four operators. This is for the multiplication. This is for division. This is for mode, and fourth one is remainder. So multiplying operators includes your four operators. The first one is your arithmetic multiplication. First sign is your arithmetic multiplication for integer and real type. Means this operator is used for your integer types and real type values. Second one is your division. This is also used for, this is slash is used for your division operator as a, and it is also valid for your integer values as well as your real values. Now real types values. Now the third one is your mode. Okay, what is mode? This is the modulus operator. So this is your modulus operator, and this operator is your have their conventional, actually your mode and remainder operator. Last is your remainder operator. Your mode and remainder operators are defined only for the integer type. Means this is also for the integer type and this is also for the integer type. But these both multiplication and your division can be of your two types, that we this can be operate on the two types of your operands, that is your real type and your integer type. So multiplying and division operators have their conventional mathematical meanings, which means we are already doing the your multiplication and your division operation, and it is defined for the operands of the same type of your integer or real. Means your both number should be of your real type or it should be of your integer type. So this was the your multiplication and your division operator. So next more about the mode and remainder operator. In this operator, this is only defined for the your you know that this is only defined for your integer type. So remainder is denoted by the, this is rem, this is the remainder operator, and it returns the remainder of integer division. Actually it this operator gives you the returns you the remainder of the integer division, and the sign of the result actually is same as that of the left operand. And in case of your mode operator, it calculates the modulus. Actually it calculates the modulus of its left and right operand. In mode we have also two operand a and b, and in remainder we also have a two operand a and b, and the your sign of the result is same as that of your right operand. Means in the remainder, we can say in the remainder we have in the case of remainder, the result has the sign of your first operand. Means this, if this is of your plus sign, then the result will be always in your plus. But if this is of your negative, then the result will be your negative. But in case of mode, the sign of the result will be depend upon the your second operand, that is your B. So this was the introduction about the your modulus operator and your remainder operator. Now I will give you the deep knowledge about the remainder and your modulus operator, how it can be calculated. Now this is the formula. This is the formula for your remainder a remainder b. When it is calculated by this formula, that is a minus a slash b multiplication with b, and the a mod b is calculated by this formula a minus b into n, and n is an your integer. Now we will do I will explain you that how we can calculate your a mod b or a remainder b with the help of one example. Now I will do the example. This will be explained by your example. Let us suppose I just want to find the 7 mod 4. Let us suppose I just want to find the 7 mod 4. As the formula for the mode, we know that is your if I have the A mod B, that will be equal to here A mod B, that will be equal here A minus B into N. That is N is an integer. Now I will calculate your mode with this formula. So how it will be possible? By comparing, you came to know that A is your 7 in this case and B is your 4. Now put these values in this. Okay. If I will put, that will give you 7 minus 4, 7 minus 4 and the integer. If I will multiply with this 2, that will be your 8 minus 7, that will be your wrong. It should be 1. It should be less than this number. If I will multiply 4 into 2, it will be more than this. So I will multiply, I will take the N as 1 in this case. So 7 mod 4 will give you 7 minus 4 is your 3. And the sign of the second operand is your positive. So its answer will be your 3. Now take the another example. Let us suppose minus 7 mod of 4. Minus 7 mod of 4. Now in this case, I will again find out your mode by using this formula. This will give you 7 minus, this is your now minus 7, A is your minus 7. So this will be your minus 7 minus of 4 into, it should be your minus 7 minus 4. It should be your into that should be your into 2. So it will give you minus 7 minus it should be your it should be your 1, not 2. It will be greater than this value. So it will give you minus 7 and it will give you minus 7 minus of 4 into, it should be your minus 1. So it will give you your 7 plus 4, that is give you minus 3. So now you know that the sign for the second is your positive, but answer is your negative. So in front of that, if I will put this will again written like this, minus 3. Okay. So minus 7 minus your mod 4 is here minus 3. Okay. Similarly, if I will take as 7 mod minus 4, 7 mod minus 4. So in this case, 7 is your of plus, B is of your minus 4. So 7 minus of minus 4, it should be your 2 now, because minus 4, 7 minus your minus, it should be your minus 8. It should be your 7 of minus 4 will give you this will give you minus 2. Minus 4 into minus 2 is your plus 8 minus 8. This will give you minus 1. So this will give you minus 1. Now the last is minus 7 minus 4. Similarly with this step, it will gives you that is your minus 3. This will give you, after calculating all this will give you minus 3. So this is this was your mode operator. Now if I will explain, so in the case of using this, in the case of your remainder, you can also apply the formula A minus A by B a by b, that is a minus a by b into b. So with this step, we can also calculate the remainder. So in case of remainder, we will use the formula here. Your formula as here. Your formula a minus a b. So with this help, we can calculate the remainder. Also, we can calculate your all the variable, all the your operators. So now one more example. We can do this example with the remainder also. We can do this example with the help of your remainder also. In the case of remainder, you will use only your that formula. So in case of, let us suppose I am taking the example as 9 minus 4 or 9 something 4. So we can do in that manner. So with this, I will explain you now the remainder with some of the examples. Okay, I will explain this remainder and more with one more example. That is here, if I just want to find out the mode and remainder for the example 9 comma minus 5 means a is equal to your 9 and 5 is your b. So how it will be calculated? So in the next example, I will show you 9. Find the mode and remainder for the 9 comma minus 5. It means your a is equal to 9 and b is equal to minus 5. Now, how I will calculate this? Let us suppose, firstly, I just want to find the mode. 9 mode of minus 5. How it will be calculated? How it will be calculated? By the formula I have already told you. In this, how you can calculate this? I will write like this: 9 minus 5 into 1. Sorry, 5 into 9 minus 9. I mean 9k, we have to just equate to it 9. This value equal, I have to just put the formula like that. It should be equal to 9. So it will be, gives you minus 5 into minus 2, minus 5 into minus 2 and minus 1. So it means 5 into 2 is your 10, minus 10. Sorry, this will be minus minus plus 10 minus 1 will give you 9. So I will write 9 in this manner: minus 5 into minus 2, and then this is the integer form. So minus of 1. I will write like this. So your 9 mode minus 5 will give you, this is your answer. Integer part is your answer. So this will give you minus 1. This will give you minus 1. Now if I just want to find the your remainder, okay, remainder. So in this case, 9 remainder of your minus 5, I have to again do the manipulations like that. It should be equal to your 9. So how is it possible? It should be minus 5 into minus 1, and this will give you plus 5. Okay, this will give you plus 5, and it should be plus 4. There should be, for making it 9. So it will give you 9. Then this 4 will be your plus of 4 will give you the remainder. So with this method, we can calculate your mode and remainder. Now, if I am taking the another example, 9 mode. Next example, I will take this, and then we will do minus 9 comma 5. Minus 9 So in this case, I have to find the mode and remainder. By again, I have to now make it as your -9. I have to make it as your -9. So for remainder, it will be -5 into 2. This will give you -10. Then, but I have to make the -9. So +1 should be there. +1, it will give you -9. So +1 is the answer for your -9 mode 5. In the another example, 9 remainder -9 remainder 5. In this case, again I will multiply with 5 into your 5 into your -1 plus 4. 5 into your -1 -4, because this will give you -5 and this will give you, sorry, this is -4. This will give you -4. Then it will give you your -9. So -4 in this case your remainder. So this was the explanation for your mode and remainder your operators. Now moving further with the next operator, that is your miscellaneous operator. Next operator is your miscellaneous operator. Miscellaneous operator. In this we have two operators, and second is here this. Actually, this sign is for your exponential operator, and second is your absolute value operator. So first one is your exponential operator, and second is your absolute value operator. So this is the miscellaneous. In this miscellaneous, we came to know that in the case of your miscellaneous operator, we have two operators, exponential and your absolute. And third is also in this case, third is not sometimes not is inversion is also included in that, but basically there are two, exponential and your absolute value operator. In the case of exponential operator, left operand means if you want to find the A exponential of B, then left operand A, let us suppose A exponential of B, you want to find that. In that case, your left operand, that is your A. Your left operand here should be of your integer or floating type, and your right operand, that is your right, that is your B. It always should be in your integer. It should be in your integer. So this was the exponential operator, and next is your absolute operator. So absolute operator is used to find the absolute value of a numeric operand. So absolute value actually is to find the ABS operator is used to find the absolute value of the numeric operand. Now the next one is here. Now the next one is here, assignment operator. So in the case of your assignment operator, Next is your assignment operator. In these operators, we have three types of operators under this category: assignment operators. In this, we have less than equal to, colon equal to, and here this sign. This is used to assign a value to a signal, and this is used to assign a value to variable, assign a value to a variable, constant or generic. Constant or generic. Now the last piece here, operator is here used to assign values to individual vectors or with others. Individual vectors or with others. So there are three assignment operators in the VHDL. These assignment operators are used to assign the values to your signals, variables, or constants. So first one is less than equal to sign is used to assign a value to a signal. Colon equal to is used to assign a value to a variable, constant, or generic. And the third symbol is used to assign the values to individual vectors or with others. Now I will show you the one example that how a signal or the variable declarations are done using these operators with the help of example. So example is like that: signal A is equal to signal A colon standard underscore logic colon semicolon. Signal B is of your standard underscore logic vector vector 3 down to 0 semicolon. Next is signal C colon standard underscore logic vector vector 0 to 3 semicolon. Now assignments, how assignments will be done? First is A less than equal to 0 semicolon, B colon equal to 1001, C less than equal to 0 1 comma others 0 others 0. So signal A is of your standard underscore logic, and it's the value assigned for this will be like this: A less than equal to 0 means I have assigned the value using the less than equal to operator because it's a signal and it should be in the single place. Now B is of your vector type, so means it's a variable. 3 down to 0, it can be 1001, 1100, 1001, 1010. Means it's of your variable type. It's a 4-bit 3210. So its assignment will be with the colon equal to B colon equal to of double quote, that is 1001 value semicolon. Next is your signal C of your standard underscore logic vector and having the 4 bits 0, 2, 3 means 0, 1, 2, 3, that is of 4 bit. So in this case your MSB here should be 1, 0 means your MSB 0 means your MSB your, or your, you can say LSB your, some in some books it 0th place is your 1, it should be taken as 1 because LSB is written over here, and others should be 0, others 4 should be 0. But now 0 to 3, first position is 0, 1, 2, 3. So at 0 position it should be 1 and it shows the LSB. Okay. So now rest of the bits, that is other should be 0. That is here assigned by this symbol, third symbol. So C is less than equal to this. This will be equivalent to here this. So LSB is 1 and other bits are 0 in this case. Now with this we have completed our explanation for the VHDL operators. Now we should know what type of your operators have the highest priority or highest precedence. Now according to that highest precedence for the your among all the operators is like this. I will make one table for that. Highest is here for miscellaneous, highest of your miscellaneous, and this shows the, this is your highest, this is your order of precedence for operators. Second one is your multiplying. Third is adding. Fourth is shift. Next is your relational. And last is your logic. So this is the highest, this is the lowest. So in that order we have to deal the different your operators. So evaluation rules, there are some evaluation rules. First rule is that operators evaluated in order of precedence, highest are evaluated first. Now the second is, if operators of equal precedence means multiplying, adding, shift, relational, it should be evaluated from left to right, means multiplying means first miscellaneous, then multiplying, then adding, then shifting, then relational, and then last is logic. Third rule is that deepest nested parentheses are evaluated first. Means if there are deepest parentheses are there, then it should be evaluated first. So these were the some of the rules to deal with the your VHDL operators. Now, if I will compile this, so if I will compile this, so there are your logical operators, assignment operators, your addition, subtraction, multiplication, division, modulus, remainder, then relational operator, then logical operators. Then data type used for the logical operators are Boolean, standard underscore logic, or standard underscore logic vector. For relational operator, we can use any data type. And here for adding, we have one-dimensional array. For arithmetic operations, we can use the data type as signed, integer floating, then integer, these all. And data type of the result in case of logical should be here same as the operand, and in case of relational it should be of result should be of your Boolean type. In case of your concatenation or your adding, it should be your of your one-dimensional array, and in case of your addition, subtraction, multiplication, division, mode, and remainder, these all having the integer or signed or your same as operand. Your data type can be of your same as your operand. So with this, I have just compiled the VHDL operators concept. So now this is the table for the compilation of your operator. Now you can see not of A and B, A or B, A XOR B. So not is the highest precedence. Okay, and the operator class is not of A is known as your negation, A and B is your AND operation, A or B is your OR operation, A XOR B is your having the XOR operation. And the description box, these four will be related to your logical operations, and the data type can be used with this type of your logical operators, such as your standard underscore logic, standard underscore logic vector, or Boolean. And the data type for the result should be your same as the operand, means it should be of your Boolean if you are using the Boolean type, or if you are using the standard underscore logic, or if you are using the standard underscore logic vector. So now the comes to the next category, that is your relational operator. In this we have A equal to B, A not equal to A less than equal to B, A greater than equal to B. And data type used with these are type of your operators will be your that can be of your any type, or but the result always should be in your Boolean type. Now the third is here A and B, that is here concatenation, and this under the adding operation, under the adding operators. So data type used for the concatenation, that is your one-dimensional array, and your result should also having the same data type such as your one-dimensional array. Now the last is your addition, subtraction, multiplication, A plus B, A minus B, A into B, A let's divide by B, and A mod B, A remainder B. These all come under the category of your arithmetic operations integer. And in addition, we can use the signed or integer data type, and but the result always should be in the sign. In case of subtraction, we can use the operand. Operand means A and B. Operand means on which we have to operate our operation, the data. Data type should be your of the operand should be your of signed and integer in case of addition and subtraction, and but always result should be is in the form of your sign. In the case of multiplication division, data type can be used for the operand can be integer or the floating type, and the data type of the result should be same of your operand, means if you are using the integer type data operand, then your result should also be in your integer type, or whatever second type is your floating type. If your operand are of your floating type, your answer should be also your floating type. Now the last is modulus and remainder. These only having the data type as your integer, and result also should be in their integer type. So with this I have compiled the VHDL operators in detail. Now we will move further and going to the next topic, that is your entity architecture declaration. So now moving the further with this topic. Now moving further with the topic, that is your entity architecture declaration. So in this topic, I will discuss with you how you can write your program in your VHDL, and entity is the first part, and the second part is your architecture. So with this, we will start the programming part of your VHDL. So entity architecture declaration. Actually, entities used in the VHDL for the description of a circuit or the sub circuit, and are defined as a your pair of entity and the architecture declaration. The external interface of the circuit is specified. Actually, the external interface, that is your having the knowledge of your input output, that is your external interface is given by your entity. So external interface of the circuit is specified by its entity, while its operation is your is described by the your architecture body, and that architecture body is associated with this entity. So how it will be work, that is written in the architecture, and the external interface, that is your input output ports knowledge should be covered by this. So this is the entity architecture declaration. Now going further, how we can write, or the how we can what is the syntax to write the entity declaration, entity declaration in your VHDL programming. So I will write the syntax, and then I will discuss the syntax in detail, that how we can write the entity in your VHDL. The very first important part in your programming, that is your entity. Now, how a entity is written in your VHDL? So I will write like this: entity with the word keyword is your entity. It should be bold entity. Then is entity underscore name. Then entity underscore name. This is the syntax. Is, and it should be of your bold. Now next line, port. Now going further, port should be in your bold, then port name, then port underscore name, colon, mode word should be in your bold, mode, data, hyphen type, colon, then port name. Again, second port name should be written in the next line, port name, then again mode, it should be your bold, mode, data, hyphen type, semicolon. Next, again port name, the number of port you are using, port name, mode should be highlighted, mode, data, type, bracket close, sorry, semicolon, then next bracket close here. Next is and entity underscore name, entity hyphen name, semicolon. So this is the syntax used for the entity declaration. So entity declaration describes, actually we know that it describes the external interface of the circuit, including the name of the circuit, that is entity name, and your basic characteristics like input and output ports. So port, all the port declarations in that. So An entity always starts with the keyword entity. It always starts with the keyword entity and followed by its name. That is your entity name. Okay, and the keyword used is next is here is. Next are the port declaration with the keyword port and here port name and the with the keyword port. Next are the port declaration using the keyword port, and entity declaration always ends with the keyword end. Ends with the keyword end. It should be bold. And should be bold and entity name semicolon. So entity declaration always ends with the keyword end followed by the entity name. The name of an entity is always actually user defined. Entity name is here always user defined identifier. The port name is also, and the port name we are using port name, this also is of here user defined. Both input and output ports means we can use the input port also and the output, both of here user defined, and these are the user defined name to the external signals, that is your input and output both for the entity. And the port can be your single signal or list of signals separated by commas, provided all having the same type and mode. If means we can write the port name as A, comma B, comma C. If these three are of your in type, but if they are different, you are using the different, means A is using as input, B is using as output, then it should be declared differently in two lines. If both differ in the type or mode, then they should be declared separately and are separated by the semicolon. Semicolon in the syntax. Now, a port declaration in the entity is composed of port name, your port name, port mode, and its your data type. Means port declaration is further your composed of your port name, port mode, and its data type. Both port name and data type, port name and data type are of your self-explanatory, means which type of data you are using, integer, boolean, standard underscore logic, these all. And port name, it's a user defined, it can be A, B, C, any name. And in case of your mode, the term mode actually indicates the direction of the signal, which can be in, out or buffer. Means mode can be of your in, out, or last is your buffer. Means your mode can be your, there are 4 port modes. One is your in, means signal will be entering in the circuit, and the signal which is going out of the circuit, that will be of your out mode. In out means if a port can be your, can be operated as your input mode as well as your in mode or your out mode. And last is your buffer. Now I will explain you the in mode. Firstly, the port is only of your input, its value can only be read in this case. And in any assignment statement, the port should appear only right hand side of the statement. Means your port should appear always on the right hand side of the statement. In any assignment statement, it should be on the right side. Now come on to the second port, that is your out mode. The port is only an output port, its value can only be updated. In the first case, in mode case, we just read the value, but in this we have to update the value in case of your out mode. In any assignment statement, the port should appear only left hand side. It should be your left hand side. It should be on your right hand side in case of your assignment statement. Now the third one is here in out. The port can be used as both input and output. Its value can be both read and updated. In this case, means we can also read the value, we can also write the value or update the value. Now last one is here buffer. Last one is here buffer. In this mode, port mode, the port can be used as both input and output, and its value can be both read and updated. But what is the difference between in-out and buffer? It differs from the in-out mode in that it can't have more than one source, and the only kind of signal that can be connected to it can be another buffer port or signal with at most one source. Means in this case it can't have more than one source. Means only one source should be there. Only one source should be there. But in case of in-out, we can having the another source also. So it can't have buffer. It can't have more than one source, and the only kind of signal that can be connected to it can be another buffer port. Means another buffer port can also connected with this, with at most one source, only one source. So this was the explanation to the entity. Now in further lectures, I will explain you the entity syntax with one example. So we will meet in the next lecture. Till then, thank you, and we will meet in next lecture. Any doubt? Any doubt to any student? Please ask. हाँ जी बेटे, कोई डाउट है? Any doubt बेटे? Any doubt?
No, ma'am.
Okay, beta. With this, I am ending this meeting. Thank you. We will meet in the physical mode now. ठीक है बेटा? Any doubt? Hello?
No, ma'am.
बेटे ये सिंटेक्स याद करने हैं, ਤਾਂ ਹੀ प्रोग्रामिंग आनी ਤੁਹਾਨੂੰ। ठीक है?
आगे कॉलेज बस।
आगे कॉलेज कोई नहीं, उसे आगे याद करना है। चलो ठीक है बेटे। With this, I am ending.